Hey, this is chapter 32 and the last chapter of the semester also. We'll be talking about another type of joining processes this time. They are not about welding, but we will be talking about brazing, soldering. These two are very similar to each other. And then we'll be briefly talking about adhesive bonding. And lastly, we'll have a look at some examples of mechanical fastening processes. And in the brazing and soldering, we don't have any diffusion as opposed to the previous processes we discussed in chapter 31. We make use of a filler metal. The difference between brazing and soldering is actually the melting point temperature of the filler metal. If it is above 450 degrees, then that is called as brazing. But if the melting point temperature of the filler metal is less than 450 degrees, then that is called as soldering. But other principles are the same in these processes. Now let's start with the brazing process. You can have a look at a simple example of brazing process here. These are the two parts to be joined together. And what we do, we apply some brazing metal, and this is a kind of a wire this time, and then by different means we melt this wire, and then with the help of the capillary reaction, actually this metal, this secondary metal or filler metal, goes into these cavities in between the two parts at the interfaces, and then once it's solidified, we obtain a bond between the products. And there's a kind of a liquid solid state bonding process, since we melt the filler metal, but we don't melt the parts to be joined together. And these are the things I discussed. So mostly for filler metal, we use brass, and with the help of heating, we melt it, and that brass actually will be going into the cavity with the help of the capillary reaction, and after solidification, the joint is obtained. And here are some example designs for brazing. These are also similar to soldering. So we need to have a very fit actually gap. The width of the gap shouldn't be too much in the brazing operations. But if it's highly small, then the material cannot go in. But if it's larger, then we cannot fill all these gaps with filler metal. So that should be at optimum levels, usually around some maybe less than a millimeter or some millimeters. So depending on the type of base metal, we need to use a proper filler metal, since the chemistry between these metals are highly important. And here are some typical melting point temperatures of the filler metal. As you see, they are always above 450 degrees. So that is the distinction limits. Above it, it's called brazing, and below 450, the process is called soldering. And as similar to some welding process, we need to use fluxes so that we will have less oxidation, even maybe it's eliminated totally. With the help of it, we are not generating any oxide films or around the product. And the strength of the joint actually depends highly on the gap between the products. If it's smaller, we will have a higher strength. But as I said at the beginning, if it's too small, then you may not actually fill the gaps with the molten metal. So you should find the optimum gap between the products. We have some types of brazing methods, but they only depend on the type of heating mechanism. So if you are using torches in order to melt the product, then that is called as torch brazing. If you make use of a large furnace, it's furnace brazing. If you make use of induction heating, it is induction brazing. If you make use of electrical resistance, then it is resistance brazing. And if you make use of a pool and then put your products actually into that pool of filler metal, then that is called dip brazing, and that is mostly suitable for mass production. At a time, you can join thousands of parts together. And if you use quartz lamp, then that is called as infrared brazing. And if you have diffusion between the atoms, then that is brazing, diffusion brazing. And if you use beams, laser beam, electron beam for the heating of your filler metal, it's called high energy beams. And lastly, if you use actually more filler metal than the other brazing methods, it's called as brazed welding. Not a brazing, but it's brazed welding, since it's very similar to the welding process where we use filler metal if the gap is quite larger. Then let's briefly talk about soldering. As I said, the difference with respect to the brazing is that the melting point temperature of the filler metals is less than 450. We make use of this process for mostly in electronics industry. We join actually the chips, the resistors, the capacitors, there's some electrical components on the boards with the help of soldering. And since the lead actually, which is the most popular material for soldering operation, has some toxicity, so that's why these days we are switching to some tox-free or lead-free type of solders. And as you see, similar to the brazing methods, we have different types of soldering. I'm not going to discuss them one by one. So torch soldering means we are using torch. Infrared means we are using infrared. Ultrasonic means we have some kind of ultrasonic waves. With the help of them, the metal wire is melted. So these are some typical ways of soldering. And we have a term solderability. It's very similar to weldability. So if the metal parts can easily be soldered together, then they have high solderability. For instance, copper, silver, and gold are easy to solder, but on the other hand, we have some other materials like aluminum, stainless steel, iron, nickel. They are difficult to solder. So what we do, if you want to solder them, then you need to do some plating first with some solderable metals, and then later do the soldering operation. You can see some joint designs for soldering and somehow similar to a brazing. So we should have little gap between at the interface between the products, and then again by melting our filler metal, these gaps will be filled with filler metal. Now let's talk about another type of joining process of this chapter that's called as adhesive bonding. And as the name implies, simply we are using some special chemicals like adhesives. They are usually in the form of rubbers, polymers. We simply pour them on this interface and then apply little pressure, and the parts are joined together. For instance, the plywoods are mostly made of using adhesive bonding. And in this process, the adhesive actually should have high strength, especially for shearing and peeling of actions. They should have high toughness, since there might be some high vibrations, impact forces. Your adhesive bonding should withstand to such cases. And another thing, you may be pouring some chemicals, some other fluids on it, so that your adhesives should be withstanding to the high amount of chemicals around, or some degradation, some heat. They should have such resistances to heat, chemicals, fluids. Otherwise, the life of the bonding will be very low. What are the types of them? Types of adhesives? We have natural ones, inorganic ones, synthetic ones. But the most popular one is the synthetic one, like using thermoplastics or thermostats. And you should be checking some guidelines. For instance, one may be suitable for metals, but the other one may not be suitable. One is useful for wood, other one may not. For instance, we have a nice table here. For instance, for metals, ceramics, epoxies are mostly used. So that is for wood. For instance, we use such nano, phenol kind of things. That is a nice table for this for making some decisions on the right adhesives. And if you want to actually do the soldering at very low temperatures, then you may use some electric conductive adhesives. That's why it's not a pure soldering operation. It's somehow an adhesive operation. You can see, for instance, by using such a simple syringe, you may join these components together. Now we have the last group of actually joining process in this chapter. They are all about mechanical things, and we use some kind of actually bolts, nuts, and screws. With the help of these, actually, the service life of the product, the assembly is improved. Since it's not like brazing or soldering, since if you do other joining process, you need to collapse the parts or break the assembly. But if you use mechanical fastening methods, then you can easily remove them and then check your product, do some service on it, and then use the same fastening items. And with the help of it, the service life can easily be improved. So we can say that by using mechanical fastening, the manufacturing is eased. We have easy assembly operations. This assembly is also not that difficult. We can easily repair the products. We can easily design some complicated things. We may use some hinges, some sliding mechanisms. They are all possible with the help of such mechanical fastening. And we will be talking about some types of these. The most popular ones are threaded fasteners, like the bolts, screws, and we use them all in almost all assemblies, almost in all products. They may be smaller or larger, and they usually have good strength. They can withstand the shear forces, and they can obviously increase the service life of the overall assembly. In addition to them, we use some rivets. They are not obviously, they don't have any threads on the surfaces. We use them in even buildings while joining some steel parts together. We have some examples, as you see, some types of rivets. You see there are various types, and we usually have some special guns, special equipment to do this riveting operations. And we have stapling. Stapling is very similar to the stapling of papers. We have metal stitching or clinching, and this one we place some parts together on top of each other and then apply pressure with the help of little plastic deformation. We will be generating an interlocking geometry on some regions, and that is then again a kind of a mechanical fastening. Then we may have seaming process, kind of if you bend some sheet metals on top of each other, as you see. That's a nice example of seaming. Then we have crimping. In crimping, we need to have some beads and dimples. Let me show you that. Yes, it's an example of crimping. You see, two cylindrical parts are crimped together with the help of these actually necks and some dimples. Then we have spring and snapping fasteners. They are highly suitable. For instance, these are the things, if you have such proper designs and push your product, let's say this blue one, into the opening, then you see after it goes through this opening, you have such extra, let's say, features here, and you cannot easily remove them. This is another one, and that is mostly used for simple boxes, and it's highly utilized in plastics industry. And then we have shrink and press fits. In the press fits, we apply some pressure so that the parts will be joined together, but it's quite difficult to remove it after the parts are joined. And the shrink fit case, we use some heat, we cool down the product, or we apply heat so that its size will increase, and then with the help of it we can join the products. And that's actually all for this chapter and also all for the semester. And I hope you enjoyed this course, and see you in the oral examinations.